hearing anybody right now.
It is recording.
It is recording. Could somebody else type into the question box just quickly whether you can hear us or not? Let's see. Nina can. Okay, so Rebecca, it might be on your end. Megan can hear. Okay, Rebecca can hear us now too. All right, so we'll continue on. Thank you. Thank you. So you will all be muted unless you raise your hand for a question at the end, and then I can unmute you for you to ask out loud, but most people prefer just to write their question into the question box and have me ask. And also at the very end of the presentation, as you're exiting the GoToWebinar viewer, you will be asked to fill out just a real quick online survey that will give Tim and the CauseWeb people information about how you'd like the webinar. So I'd like to pass this over to Tim Jacobbe now. Thanks, Tim. Tim, I can't hear you. Are you there? All right, hang on, everybody. We're still working on that.
Hello, can you hear me?
Yes, Tim, great. Okay. All right,
great.
Go ahead, Tim.
So sorry about that delay, everybody. So thanks for joining us on this webinar talking about teachers' understanding of statistics. To give you an overview of the type of things we're going to talk about today, I wanted to give you an overview of the LOCUS assessments. I'm sure many of you have heard of them and others have not, and so I want to give you an overview of the development and what went into that, talk about how teachers have performed on LOCUS, and then to go into some materials for teacher development. I wish I could provide an exhaustive list of all the materials that are available for teacher development, because there are a lot of great things out there from our colleagues. But I am presenting what I can, and I apologize if I've left anybody out. But any suggestions you have at the end would be great too. So to give you an idea of the LOCUS project, I just want to first acknowledge the tremendous team of principal investigators that we have on the project. Bob Delmas at the University of Minnesota, Jeff Haberstroh at ETS, Brad Hartlaub at Kenyon College, and we have some great research fellows here at the University of Florida working on the project, who many of you have met in various circles. Furthermore, I mean, we just had an incredible team to create these assessments. The advisory board speaks for itself, as you can see. And then for the beginning and intermediate levels, which were meant to assess grades 6 through 9, and I'll get more into detail with that. You can see the development team there, and I believe Jerry Marino is on this webinar, so I'm going to say hi to Jerry and thanks to him and everybody else for all their great work on developing these assessments. And then the intermediate and advanced teams included another great collection of individuals. So without further ado, just talk about the goals of LOCUS. We wanted to develop instruments to assess levels of statistical understanding as identified in Common Core as well as the GAZE framework. The authors of the GAZE framework fully acknowledged that they neglected the A in the development of that framework and didn't really discuss assessment very much at all. And I have extensive experience in test development and have seen and evaluated the way statistics has been assessed on large-scale assessments. The literature has also spoken about this issue in the field. And so one of our goals with LOCUS was to change the way statistics is assessed. And then furthermore, we wanted to provide a characterization of the level of understanding of statistical topics. And the grant was really written for students, but we also acknowledge in the literature it talks about how teachers' understanding of statistics may not be that different than students' understanding, given that there hasn't been much done in the area of preparation of teachers. And so we have also looked at how teachers are doing on these assessments. And then furthermore, we wanted to provide a tool for researchers and teachers to assess growth in statistical understanding, and for that purpose, we developed, there are 2 forms of the assessment, Form 1 and Form 2, that can be used for pre-test and post-test purposes, both for teaching and for research. And they have, we have papers coming out with the validity and reliability measures on that, but that's not the topic today. To go into our assessment development process, trajectories from statistics, education, research, and then the advisory board, who you saw, that esteemed group, used that information to develop evidence models or statements of evidence, and I'm going to give you an example of that on the next slide. So we developed this evidence model to provide the blueprint for development of the assessment by the test development committee during the assessment implementation phase. We also piloted our assessment items with approximately 4,000 students in 6 different states. And so we took all that information to develop the final forms of the assessments, and then we are now in the assessment delivery phase where we are disseminating results. So to give you an idea of what the evidence model looked like, this is an example of how an idea progresses across levels A, B, and C of the GAZE framework. I assume everyone on the webinar is familiar with that, but obviously you should consult the GAZE framework to talk about how students' understanding should progress across these levels of development. So I'm going to give you a minute to read this before I go on. Keep in mind that in addition to this, what's on the screen, there were 2 other columns as part of this blueprint of the assessment. One was upper observable features, the other was lower observable features, and the purpose of those were to articulate what it means for a student to exhibit high levels of understanding at a particular domain and versus a lower understanding. So. Okay, I can come back to this toward the end, and we are also going to be in the next few months going to be posting the full evidence model on our website, which I'll be sharing as well. So, the GAZE framework identifies 3 levels of development, A, B, and C, and ideally students would be exposed to level A content in elementary school, B content in middle school, and C content in high school. And this is all that the LOCUS assessments address. It's pre-AP statistics, so we are not dealing with content that's generally in the introductory statistics course. There are 2 levels of the assessment that we created, beginning and intermediate statistical literacy and intermediate and advanced statistical literacy. The advisory board felt strongly that level B should be represented on both assessments, and so levels A and B on the beginning and intermediate, and levels B and C are assessed on the intermediate and advanced. The other thing that's highly prominent in the GAZE framework is the statistical problem-solving process. And so LOCUS really was designed around this process and trying to assess this process. And so, in terms of emphasis across the overall assessment, we have formulating questions, collecting data, analyzing data, and interpreting data. And you can see the percentage of emphasis on each of the assessments outlined here. The thing to note is that the advisory board again felt strongly that formulating questions and collecting data should comprise a total of 40% of the assessment, and analyzing and interpret should comprise 60% of the assessment. So, even though there's a range of percentages, if you look, we made efforts to keep it at 40 and 60%. And the again, focus of this talk is not on this, but the validity shapes out to report at the formulating and collect level, as well as the analyze and interpret level, as well as the overall arching, statistical literacy measure. Okay, so one thing I wanted to do next was to give you an example. We don't have enough time to provide 10 examples in each category, so I wanted to provide you with, one example in each of these 4 categories, and then go into how teachers and then how students have performed on these assessments. So this is an example of formulating questions. And this item was administered to students in grades 10 through 12. It was considered a level C item. So again, I will give you a moment, and as you're reading through, consider, what percent you think got this correct versus what percent went for each option. Okay, so if we were in a live audience, I'd be, polling you to decide what percent went for each option. But the correct answer is option B. And 19% of students in grades 10 through 12 got this item correct. The most popular distractor was option D, where 40% of the respondents went for it. 29% went for A, and 11% went for C. And so this is just to provide you a snapshot of what we mean by a question, around the formulate questions idea. So we're going to go into a collecting data item, and this again also assesses students in grades 10 through 12. Okay, so students did very well on this item. 91% got it correct, with the correct option being option B. And so there weren't many students that missed it at all. The most popular distractor was option A, with 6% of the students going for this particular choice. So the next item contrasts that result, and so we're getting into the analyzed data. And we actually found out that our analysis of data items, which I'll go over a little bit later, tended to be the most difficult portion of the test. And one could argue that the curriculum, if it has taught any of the statistical problem-solving process, their focus has been on the analysis of data as opposed to formulating questions and designing studies and interpreting results. Many of the people we've talked to in our analyses are showing that the reason why analysis is becoming the most difficult is we weren't asking straightforward, just calculate the mean or find the median, which is most common on standardized tests. We were asking them to do things in ways that involved more than calculation. So in this particular item, students, and this was administered to students in grades 6 through 12, so it was actually on both the AB or on the beginning and intermediate and advanced forms of the assessment. And so I didn't put the whole item with options here, but it basically, you can see the stem of the item as well as the prompt, and it asks in which grade level did they vary the most, 6, 7, 8, or 9. So this item's been, this type of item's been common in research literature, and so it's probably not a surprise that students did not do very well on this item. Only 13% got it correct, with the correct option or choice is grade 7, and the majority, as I'm sure you can also guess, went for grade 8, and 85% of students went for that particular option. So we are going to go into our last example of interpret data. This was a level C item that was assessed, or used to assess students in grades 10 through 12. So this A. Okay, so now I want to, the data that I've been sharing with you so far has been around the idea of teachers' understanding of statistics, students' understanding. Those were the percentages that I've been sharing. So to get into how teachers were doing on these types of items, we are going to look at, their collective responses or percentages across the 4 categories as well as overall in the assessment. So you can see there that pre-service and in-service teachers, sample sizes are fairly large, with 268 pre-service teachers and 493 in-service teachers. They're doing best on the formulation of questions, and they are, doing not so great on the other categories. The overall percentages, 69 and 74%. There's no difference between these two groups statistically, and so this is just to provide you a snapshot. We also isolated in our study AP Statistics students. Now these assessments are given to students at the beginning of AP Statistics, so they haven't had the course yet. So just to compare how teachers are doing, in relation to how students are doing generally in grades 10 through 12 in an that are enrolled in an AP statistics course but haven't actually taken the course yet. So as you can see, there is quite a difference, but they're lower than what we might anticipate or hope for, given that they are going to be teaching this content. So one thing to point out is there is a statistical difference actually between how teachers did versus how the students did on the assessment. So we can say teachers significantly outperform students, but we have to ask ourselves, are we really satisfied with this type of performance? Because, you know, the teacher performance is encouraging, considering there has been limited training, and many articles in the literature talk about how students and teachers' understanding isn't different. Well, what we have in our preliminary analysis here shows that it is statistically different. Teachers do have a better understanding of statistics than their students do, but the issue is that LOCUS measures statistical understanding expected of students in grades 6 through 12. I want to be very clear that I don't blame teachers for this lack of understanding. I think it's our responsibility as faculty to engage teachers, to engage teacher preparation programs, and ensure that statistics becomes an essential component of the professional development of teachers, both in service and pre-service teachers. It's unfair that we've been increasing the expectations for teaching statistics for all these years without ever really addressing teachers' preparation. And so the hope is, with LOCUS and with other movements and Common Core and all the testing movements, which I am not necessarily a proponent of all of those, but I also realized, and part of the whole premise behind LOCUS was to try to have an impact on the way statistics gets assessed, because if we can change the way it gets assessed, then that is ultimately how we might be able to change the way it gets taught in the grades of 6 through 12. So the timing of this talk is actually quite perfect, because today the American Statistical Association has released the Statistical Education of Teachers report. It's available at that link. It's basically amstat.org/education/set. And this is a document that provides recommendations for what should be done to prepare teachers to prepare them to teach elementary school, middle school, and high school. And so this is a phenomenal document that will hopefully provide some guidance into what we should be doing as a field. And this document will hopefully be able to be used in state departments as well as, you know, in the college setting to argue for additional coursework in the area of statistics, which we've just seen is an area of need. There are other resources, the GAZE framework, of course, that are developed by ASA and NCTM. Making Sense of Statistical Studies is a great resource for addressing some of the components of the statistical problem-solving process. Bridging the Gap between the Common Core and teaching of statistics and developing essential understanding of statistics, an NCTM book that's made to develop in-service teachers and pre-service teachers' understanding of statistics across grades 6 through 12. So the one thing I want to point out is Making Sense of Statistical Studies, as well as Bridging the Gap, you know, provide materials that are appropriate for students. I think our results that we just went over reveal that might be okay. You know, I've run many workshops where Bridging the Gap activities have gone over incredibly well with teachers. Not only does it model appropriate pedagogy, but the teachers need that support themselves, because most of this content is in an area that they have not necessarily been exposed to. Other ASA resources, just to quickly mention, are STEW, Statistics Education Web, which is an online journal of K through 12 statistics lesson plans, the Statistics Teacher Network, which has a very large collection of articles that have been written to be used in the classroom, meeting within a meeting, and then census at school. There are also ongoing projects that I'm highlighting 3 here, but there are many more that, you know, focus on the development of teachers' understanding of statistics. You know, Sue Peters is doing a project at the University of Louisville, developing professional development materials. Holly Lynn is doing a MOOC. Right now they're actually using LOCUS to assess teachers' understanding pre and post. And then Project SET, which is Anna Bargagliati's work out in California. So In addition, obviously there's LOCUS, and this is the website for LOCUS, locus.statisticseducation.org. What I would love for everyone on this webinar to do is to go ahead and register for an account. You just click Test Giver and you come to this page. If you don't have an account now, you just click Create New Account, and I'll get an email, and we'll be in touch about the process for creating an account. So it's a great resource to use both in formative ways as well as in research if anyone's interested. It also provides a great snapshot of the way statistics is hopefully going to be assessed coming forward in grades 6 through 12. So our next steps for the project is to develop a website that's aimed at professional development. We have made significant progress on that in the last few months, where we are developing commentaries to go along with a lot of our items, and we're going to provide sample items as well as common misconceptions that are revealed in the items, and then we will also provide the evidence model to show about how statistical understanding could progress across the grades and across levels of development. We also hope to continue to influence statistics items on high-stakes assessments. I'm pleased to report that we are having an impact in providing example items for the testing industry to use, all the way from the state level assessments to the PARC and Smarter Balance, which don't have as much of a following anymore, all the way up to the Reform SAT that's coming out. So we are making an impact by providing a lot of these example items, and so we are hoping that ultimately we will change the way we assess statistics, so that way we can change the way we teach it. But the first step in changing the way we teach it is for everyone on here who's most likely already involved to get involved with teacher preparation, because there is clearly a need. So I just wanted to thank you for participating and watching, and later on tonight or whenever. And so and that's my email address if anyone wants to follow up. And I believe there'll be some question and answer now.
Thanks very much, Tim. We do have a few questions rolling in. Catherine wants to know, what statistical training do the teachers who were tested have?
That is a great question. Pretty much and I can't answer it collectively, it wasn't one study that collected all 493 responses from the in-service teachers, or 268, but most of them were done in a setting in which they were starting to get professional development. So they've gone through a degree program, they have their degree, but during that degree program, many of them have had an introductory statistics course, but that is all that they've had. They haven't had any courses focused on teaching statistics in grades 6 through 12.
Okay, and could you go into a little bit more depth about why you think there is no statistical difference between pre-service teachers and in-service teachers on this test?
Sure. My assumption on that, again, don't know for sure, but my assumption would be that neither in professional development or have teacher preparation programs changed enough yet to now incorporate a lot of the statistics that are expected in the Common Core. The thing to keep in mind with the pre-service teachers, the reason why we were able to collect data on that is that was generally done by a researcher who was developing a statistics for teachers course. So presumably that at the end of that course they will have a better understanding of statistics, and that hasn't been administered yet because these are just beginning with the start of the semester. Holly Lynn's project, which I mentioned, is that MOOC, and so this was designed for teachers to take prior to they took it as a pre-test so far, and they haven't done the post-test if that wasn't included in this analysis.
Are you seeing more interest in statistical training for teachers now?
Very much so. For the first time ever, I've given workshops to schools all the time focused on problem solving, formative assessment, how do we develop elementary kids' understanding of number concepts. Those are always the topics for focus. But most recently, I've been getting a lot more requests to focus on statistics. And so, in fact, I'll be doing a 4-day workshop in Palm Beach coming up, because they realize that they have a lack of understanding in the area of statistics in relation to what's coming out on these state assessments. And that's where I think it goes back to, if we change the way we assess, then we can change the way that, the focus of statistics in the classroom. And I'll put in another, caveat here that I don't blame teachers for focusing on statistics now that it's becoming more of a part of the assessment system, because we, again, as an education system, probably focus on the wrong things in terms of how we're evaluating our teachers and the emphasis that we put on it. And so, I don't blame them for focusing on what's on the test. What I have had an issue with is the way that we're testing it. If it's a bad test, basing teaching on a bad test is not a good thing. So hopefully we can change that.
Okay, Nina wants to know, in a teacher education program for middle school teachers, where many teachers take the general freshman level stats course offered by the university, would working in a separate course with materials aimed at students be too low level?
Can you repeat the last part of that question?
Sure. So for the special teacher class, after they've already had the general intro stats class, if you had the future teachers working with the materials aimed for students, would that be too low level? Well,
I would make the argument of similar to the Van Hille levels of geometric thinking, and I don't know if you're familiar with that, but there was in the original work by Van Hille, there was a statement in there that if we teach at a level that exceeds that of our students, we may be able to teach them to imitate what we do. But we will not be able to teach them to understand what we're doing. So I would argue that if it's, they've had the intro stats course, this assessment, it wasn't again a focus of this talk, but it's been used with intro stats students both pre and post introductory statistics courses, and they are not necessarily showing understanding of a lot of these topics or concepts either, and this is exactly what they're expected to teach. So I would argue, focusing in this area by modeling good pedagogy and then showing how we can develop these assessments or not assessments, activities, and develop this understanding, and then using LOCUS as a way to capture that wouldn't be necessarily a bad idea. And that's been done in a lot of the pre-service teacher courses that I'm aware of.
Okay. Sharon wants to know if you are addressing probability in LOCUS.
Very good question. The answer to that is no. If I go back to the original goals for LOCUS, the first one was to develop an assessment of statistical understanding in the sense of we want to change the way it's assessed. So we had long discussions, with the advisory board and test development committee about the role of probability. We obviously use probability as a tool in some of the items, just like it's used as a tool in statistics, but we felt like a lot of probability items in, high-stakes assessments are done fairly well, and certainly there is not as big of a need, or we didn't feel there was as big of a need to influence the assessment of probability. So given that our goal was to assess statistics in terms of the way it's assessed, we chose to focus just on statistics. And keep in mind, part of that was because we had a limited number of items that we could include on the test, and so we chose to focus just on statistics, so probability was excluded.
Okay, I think that's it for our questions. I appreciate the presentation. I appreciate the involvement of all of our listeners who asked great questions. I want to remind you that that when you leave the webinar, you'll be asked to complete a short survey that will give feedback to Tim and the cause organizers. I want to remind you that next Tuesday at 1 p.m., April 21st, there will be a Journal of Statistics Education webinar on a pilot study teaching metrology in an introductory statistics course. That will be hosted by Michelle Everson. Thank you all for attending, and this presentation will be recorded and put on cause along with the slides. Thank you.
Thank you, everyone.